This video is the second in a series on the math department skills quizzes. In this case, we have the directions simplify, and we have an expression underneath a square root radical. So the strategy for simplifying a square root expression is to find as many perfect squares under the square root radical as I can. 32 is 16 times 2, and 16 is the perfect square, 4 squared. Now I'm factoring out a 2, so I'm going to move the 2 over here. X cubed literally means x times x times x, so I'm going to leave x squared here, being a perfect square, and then move one of the x's over by the 2. And then y to the fourth is a perfect square. So now I'm going to take everything that is a perfect square, take the square root of it, and move it outside the radical. So the square root of 16 is 4. The square root of x squared you might think is x, but it's actually the absolute value of x, and we'll cover more on that in just a few seconds. So the square root of y to the fourth is y squared. And then what we have left underneath the radical is 2x. Now you might be wondering, if the square root of x squared is the absolute value of x, why isn't the square root of y to the fourth the absolute value of y squared? The answer is that if I put in a negative number for y, and then square it, that squared number will become positive anyway, so I don't need the absolute value here. So to further talk about why the square root of x squared is the absolute value of x, we'll go to our TI Inspire computer algebra system calculator. So I have the square root of x squared, and it does give me the absolute value symbol. And we can see that graphically as well. If I do the square root of x squared, it gives me the V shape of the absolute value graph, and I can further verify that by putting in just the absolute value function. So here's the absolute value of x, and the red does graph right over the square root of x squared. So we verified graphically that this is the same thing.